I'm Guanlan. So I would like share some my experience and story about how to use Redis to build like next generation of the API and microservice platform, which can have the capacity run at the millions requests per second scale. So who am I? Let me introduce myself a bit. So I'm Guanlan. I'm leading the core, Cloud, and AI machine learning teams. And I'm also a OpenResty contributor, which is awesome open source contributor. I'm going to talk that a little bit later. Before that, I was the tech lead in Cloudflare, which powers 12% of the internet traffic. So like that's the place I started my journey with the open source community, and also that's the place I heard Redis and how to use Redis for relimiting purpose. It's definitely an awesome open source projects to have. So I'm gonna talk a little bit about Kong. Have you ever anyone heard Kong before? Raise your hand, please. Oh, thanks for the commoner here. So what we do is we are most popular open source microservice API platform. What we did, we have provide a microservice management tool for the open source community. We have right now more than 140 contributors from all around the world. And like just last year, we get 20,000 stars on GitHub. Right now, we are the most popular projects. And when you thinking about using some tool to manage your microservice, so think about Kong. What Kong does here is Kong helps developers to discover the servers, to extend them, to protect them, to consume them. So in fact, we deliver what we call servers control platform, which can get developer on top of a lot of moving parts and different architecture patterns. For example, if you are in the traditional company, you might have modern Linux, you have microservices, or you are on the journey towards serverless. There's lots of a great topic today, talk about serverless. And the vision of the Kong is like we're gonna support all of them. And like also the Hibernate world in the enterprise world, we kind of like get developer provide visibility and help them to get the business value of the microservice. There's a couple of things like underneath the Kong. We are sort of like use some of the key functionality with Redis, which I'm gonna give a couple of examples. So first things here is the relimiting. I guess like relimiting is very kind of crucial scenario on the Microsoft world when you talk with different servers, you want to set up protection. You want to, like, when they reach certain threshold, you want to trigger, like, hey, you are reached the maximums of the limits. So what we do here at Kong, so we are using the Redis as our kind of option. You can use Redis as backend. There's a lot of like well-known algorithms for relimiting. For example, like leaky buckets, and also like sliding windows and Windows locks. And also there's a various algorithm for that. One of the things like using is like a token bucket. Token buckets has decent accuracy, and but the cons for that is you need to tune two parameters like the brass, and also it's a little bit hard when you try to actually to tuning those parameters. And also when you're using the scenario combine the distinct with operation with Redis, then will become extremely hard. So I would recommend it to use sliding window for the relimiting, especially when you have like cross multiple states, you want to share the state globally. That's Redis, like it's going to be very helpful to combine with the sliding window. The another great thing about sliding window is like a mid consumption of the previous window will be a fixed rate of the request. And the good thing about that is easy to understand and also provide reasonable accuracy. So using sliding window. To extend the sliding window algorithm, we also do is using in-memory. So we choose the eventually consistency model for this use case. One thing we have to do is like under extreme pressure for the high concurrency world. So even talk to the Redis, will introduce the latency. So in that case, we're gonna synchronize the in-memory counter with Redis like once a while. So in that case, we can reduce pressure for Redis. Another technique I would like share here is like a set then get. Is when we have like a sort of a risk condition scenario, use set then get. This kind of method is gonna significantly improve the risk condition issues here. So to recap here, so it's first choosing sliding window algorithm, then use maintain a memory table. Use set and then get for your locking mechanisms on the avoid risk condition. And last but not least is use Redis Sentinel, which is an enterprise offering from Redis. It's very helpful when you're trying to get HA on your infrastructure. All right, let's take a look on the next great scenario with Redis is caching. So when you have like a proxy, you have like a management tool for your different servers. A good use case for that is caching. Why the caching is important? So like there's like a joke, like there's a 3 hard disk problem on the computer side. So the caching is one of them. So like how to use the caching efficiently and also to use caching like correctly, which is extremely hard. So one of my colleagues, Thibaut Chamberlain, he has open source a great kind of library called like ML caching. What we do here in Kong is like we maintain 3 layers of caching. First layer, we use LRU, which is the least recently used caching. We maintain there per worker. So in that case, if we have caching on the per worker, we don't crash our Lua VM. So that's the first layer of caching. It's also the fastest one we call L1 caching. The second layer of caching is shared disk cache. So shared disk cache, we are taking advantage of the NGINX. So we are shared difference worker is our layer 2 caching. What the good thing about the layer 2 is like can share the states. So only do fetching to the layer 3 caching when all the L1 and L2 misses. And we also have to properly take care of the mutex when you talk to the Redis. So that's a good technique. We only use the mutex for the L2 level caching here. Talk about like the I/O caches and the cache miss. So we're gonna eventually talk to the Redis as the final lookup when you have like all the caches misses. The good thing about that, like you take care of the locality on the caching, and also kind of take a fully advantage of the performance here. But the only downside is it's extremely hard to make the multiple layer caching work correctly. So if you try to do that, just take a look on the caching. We already open sourced it. Just take a look on the source code. I will post on the channel for that. There will be a great library to use. To recap, so first use lots of layer caching to take advantage of the locality. And also remember, Redis is not designed to caching the big objects. So like we should really think about only caching the smaller objects. The kind of guideline I get from community is like less than 100 kilobytes. So that's definitely something you have to think about very carefully. Another kind of technique is to remember set TTL. TTL is expire time for the Redis. So like to properly rendering set some sort of TTL, it will definitely helps like your reduce some load from the Redis. There's another technique I would like share with you is like to have like proper case-based designing. Why it's so important to have the case-based designing? I would like to say like first, it's like make your case-based like namespace readable, like not like too short, but also not too long. Like if you have really long string of the key as a key for Redis, maybe think about it. It's the time to cache it or like hashing, apply a hashing algorithm. I would recommend to use like SHA-1 or SHA-2 for your key if it's like too long. So that's a great technique to reduce the length of the key. There's a last but not least is a twin proxy. So twin proxy is very awesome thing library when you have to maintain a lot of like a kind of like Redis connection. Those by using twin proxy, it can significantly reduce the amount of the connection to the Redis pool. So which is extremely helpful when you're in the very high concurrency world here. All right, so I would like to share a little bit like I will mention there's an awesome project called OpenResty. So the OpenResty actually is an open source platform. It's like it's kind of like a Node.js, but it's combining the kind of like a maximum performance from the NGINX. So I'm assuming you already heard of NGINX. NGINX definitely has like pretty brilliant kind of performance regarding handling the HTTP stack, TCP stack. They have extremely tiny footprint on the memory usage. So what the OpenResty does here is basically combine the power from the Lua language, have the dynamic configurable language, and also have the just-in-time compiler with LuaJIT for our projects, which can provide you with the almost to native performance, close to the C-level performance, C-module performance, and also extremely easy to development. So what we're saying here is like you are using OpenResty in non-blocking way, but without like a callback health. Like I'm sure like lots of folks like here like using Node.js before. So if you're doing things like asynchronously, there's tons of callback. It's extremely hard to maintain and to memorize them, to maintain your code. It's just too hard. By using LuaJIT with OpenResty, so you can actually write code like a very straightforward, like a blocking way to write that. It almost sounds too good to be true, huh? So let's dive in a little bit, like what's the actual power of the OpenResty provided here. So OpenResty providing a very good technique called code socket. What is code socket? It's basically combining the coroutine effort and with the sockets here. So what that means, like for example, we have the Lua runtime here. You can see if you have some call like Redis sets, Redis gets, it's normally sort of like a blocking operation. You don't want your kind of like a HTTP stack to blocking because you have to wait for I/O to doing that. The brilliant part of the OpenResty, when you're calling those kind of blocking operation, it's going to automatically yield it to NGINX event pipe loop. It will edit those events to the pipe loop. And when those events gets ready, for example, like your sockets are ready to read or ready to write, or you have errors or timeouts, it will automatically trigger and resume the event pipe and go back to the Lua coroutine to continue to execute it. So it's like compiling the two kind of great things together to provide like flexibility and also the kind of like insane performance. I will show you some like code example here. So just take a look at that. I know it's Lua, it's kind of weird syntax, but after all, it's like extremely kind of like easy to get your hands-on to write some code here. We can take a look at here. We just like allocate a new instance for Redis, and we connect to our local host Redis cluster, and then we use Redis to get set a key, doc, and also with the key values and anymore. So like in that case, we can use the Redis to get the results and basically printing the results to the browser, and then we finally close the connection. You can see here, it's like when you call the Redis set here, it automatically to yield and to the NGINX event pipe. So in that case, you actually don't have to worry about like, hey, how can I use this code asynchronously? How can I deal with those kind of like socket-ready events? Should I do like thread pool for that? No, like OpenResty just take care of everything for you. So that's the brilliant part of the OpenResty. So also like we have like a whole ecosystem around the OpenResty. There's a lot of mature library you can take a look at. So to just put in the short way, OpenResty provide a easy way to when you try to programming for your microservers, and or like for your anything related to RESTful APIs. And to think about when you need like some sort of like Redis power, definitely think about using the OpenResty platform here, which I would think is going to help you to going much further for your journings. All right, so that's the library. Here you can find on the GitHub. So like the first one is for the Redis library, which you can use to core and check your Redis core. And the other things is like a Redis limit traffic. What this library does is like give you kind of like a fast to get your hands on and like develop your own OpenResty relimiting kind of software using the OpenResty. All right, so let's see some numbers here. After all the effort we optimize for algorithm, we optimize like for the pipeline, we optimize like for you reduce the connection pool, we optimize like for different things. So let's take a look on the benchmark here. So all you can see here is like even like in the nano instance, like the cone can still reach about like 5K RPS here. So once you gradually pick it up, like for more instant, more like more like large instance, you can see there's like a cone can kind of like a scale exponentially. So it's like definitely a huge kind of like scalability we are having here. So by the way, this benchmark report is done by our third-party called GigaOn. So you can take a look on GigaOn's reports for like more in-depth benchmarks. And we can take a look on the left side. We are sort of like try to compare with other competitors. So interesting story is like even one of the micro instance like for the cone can beat the performance out of like some of the other competitors. I'm not going to name the names here. So but like just I would like to say here is using the Redis and also combining effort with OpenResty is definitely going to help your microservice to the next stage. No matter what kind of architecture design pattern you're going to have, or we can solve that and like with confidence. Yeah, I think that's everything I have here. I try to be quick because I know there's a cocktail party after that. Yeah, so let me know if you have any questions. Questions? Good?
Hey, thanks for the talk. I was wondering what kind of data structure you use for the in-memory sliding window rate limiter. What's the underlying data structure? That's the first question. The second question is, what do you see are the benefits of Tweem proxy over Redis cluster if you did an evaluation, if you considered Redis cluster? Thank you.
Yeah, okay. That's an awesome question. So I would like to answer the first question. So first question is like for in-memory, just like we are using the shedict counter, which is a counter provided by the OpenResty data structure. So it's underneath is I would say it's possibly a set. It's a set data structure underneath. But it's like just open the box to use it. You don't have to worry about it. You can think about it as a counter. It's just a counter. For the second question, talk about Tweem proxy. So Tweem proxy is kind of a very lightweight, and all this is also open source projects. And one of the reasons for that is like you can easily to set up your Redis cluster, and with the Tweem proxy, it's also provide like a consistent hashing and also like a bunch of good perks to get you started. But like when you think about like more support, like large clustering, maybe think about Redis kind of enterprise offering in some point. Like in some of my experience before, Tweem proxy also they provide the Tweem caching. So they have like separate projects. It will provide like a mem cache protocol as well. So it support like both the Tweem caching and Tweem proxy and also mem cache. So that's a good perks for that as well. Yeah, cool. Does that answer the question? Good. Thank you much. Any other questions? All right. I think thank you very much. Yeah, thanks so much.